Okay, maybe what I could do is plug in some values of a.
Alright.
So what would I want a to, if I wanted to get a better approximation of our actual tangent line, what would I want a to be? Or what would I want to, how would I want to pick values of a?
Well, I guess you would want to put them kind of closer and closer to your...
Yeah, do we have a calculator nearby? If not, I can just do it on Mathematica. Oh, we have a cat nearby. So maybe I could pick a equals 2.1.
2.1, alright.
So what is a squared minus 4 when a is 2.1?
Oh, I think a squared, that's 4.42. So, 21 squared is 4.1.
Yeah.
So it's going to be 4.41 minus 4, so 0.41.
Okay, so the top is going to be 0.41 divided by
And minus 2, so 0.1.
0.1.
So it's 0.41 times 10, so 4.1.
Okay, so here I get the slope is about 4.1. Okay, what if I pick 2.01? So for 2.1, I get 4.1. Let's see what I get with 2.01.
2.01 squared. Download that.
Okay, it turns out to be 2.01 squared minus 4. That's what turns out to be 0.0401.
And so let's see, then you have,
I have to divide that by 0.01.
Which is multiplying by 100, so you get 4.01.
Okay, so 2.01 goes to 4.01. And then maybe 2.001.
Alright.
Which is 0.004001 when I do a squared minus 4.
And you need to multiply that by 1,000, so you're going to have 4.001.
Okay, do you see any pattern here?
So you're going from 4.1, 4.01, 4.001. That 1 is actually getting smaller and smaller and smaller. So it's kind of going down. So it looks like it's, if you did this to infinity, maybe it would just, the 1 would kind of be ignored because it's infinitely small, so the slope would just be 4.
Yeah, and do you see any relationship? 2.1 to 4.1, 2.01 to 4.01?
So you're just adding 2.
Seems like you're just adding 2.
So at 2 it would be just be 4.
Seems like it. And so what I get on this this expression here, this on the top is called the difference of squares.
Yeah.
So delta y over delta x, this actually is equal to, believe it or not, a minus 2 times a plus 2 over a minus 2.
So then you can
cancel those. And so I get a plus 2, and we said we're going to try to make a really close to 2. So what does our slope get?
So our slope, a would be 2, so it would be 4.
Our slope gets really close to 4. And so we think maybe at that point the slope is actually 4. And since we know that point is 2, 5 and has a slope of 4, can we write down the equation of the line? So the point 2, 5, slope of 4.
Slope of 4.
What would the equation of that line be? It goes to that point 2, 5 and has a slope of 4.
Let's see, so let's see. So so every
Well, tell me another point that'll be on this line.
So every 4 you're going over. Every 1 you go over in the x direction, you go 4 in the y direction.
Okay, so what's another point that would be on that line?
3. 9.
Okay, good.
So, that would be 4, 13.
Mhm. So I'm going to have points like 2, 5, 3, 9, 4, 13.
So 9. So it's let's see. Those. So the x is just the value of y. And it looks like you're subtracting value. It looks like you're just subtracting multiples of 3 from that. So
Yeah, sort of. What we end up with, when the slope is 4, our equation is going to be y equals 4x plus something.
4x. So that would be 3. So you have, let's see. Would be minus 3.
Yeah, that's right.
Minus 3.
Y plus 4x minus 3. So then we just figured out the equation that way. It's pretty cool, huh?
Yeah.
All right. We'll do one more problem right now.
Okay.